There'll be a combination of some multiple choice, some matching, a little bit of fill in the blank.
Multiple
There
choice.
will not be a word bank with these fill in the blanks.
I'm gonna fail.
Some like yes or no type questions.
Okay.
And that's pretty much it. In total, it says 14 questions. Now, I caution you because the matching counts as one, so it'll be more than 14, but the set of matching. So there's one, two sets of matching on there, okay? So to start with, properties of water come up. So where we have properties of water on your biochemistry of cells, number 4, you should be familiar with the properties of water. Carbon, carbon had organic chemistry. Number 6, highlight that word. Organic is a key term there. That's one of your key terms. What does organic mean? What natural? Not all natural, but containing what? What does organic mean? No. Come on. Containing vegetables. No, it's containing something. One element. What is the element that we've been talking about a lot lately? Water. Not water. Nitrogen. Not nitrogen.
Carbon.
What?
Carbon.
Carbon. So if you have to put that
Yeah,
off
boy.
to the side of organic, that's we're dealing with carbon. We're dealing with carbon.
Now what the heck?
I'm sorry, I can't write this way.
You don't have to.
Okay? Under carbon skeletons, number 10, you should be familiar with the way that you build these molecules. So they can be in chains, right? Just a long chain. They can be branched chains, or they can be rings. Yes. Remember, when you have bonding with them, how can carbons bond? Do you remember? They can either bond single, double,
Or triple.
or triple. So how many electrons, you might want to add this somewhere off to the side as something to think about. How many electrons does it take to make a single bond? Not 6.
8.
Single bond? Yeah. Would that be 1? Not 1.
8.
2.
Dang it. That
It
was
takes
close.
2 electrons to make a single bond. So how many would make a double bond? 4. 4.
Oh, that's real good, Abby.
So how many would make a triple bond? 6. Okay? Single is 2. Double is 4. Triple is 6.
It's hard right now.
Okay, were there any questions about that? Yeah. All right. So we know the types of structures that they can make. Sorry, I need to look at eye on this.
Guys,
Okay, you should be
I only answered to
familiar
11.
with polymers and
Wasn't here
monomers.
for the
Those are
rest.
key terms right there. 16 and 17.
Just highlight
Mono means one, poly means many. Now that we've seen those. Okay. The process of linking monomers together, number 21, is called? Yes. So that process, what do you have to do? Number 22, you have to take away molecules of water or H2O. Okay?
22.
Number 26 key term. Monosaccharides are simple sugars. Number 27, the basic structure is C6H12O6. You should know glucose, fructose, and galactose are monosaccharides. You should know where they're found. So, number 29, glucose is made by plants. Fructose is found in fruits. Galactose is found in milk. All sugars have an ose ending, which means sugar. The other ending they may have is what? What other ending may they have? We don't say monoose, we say mono.
Second.
So saccharide also means sugar. Saccharide also means sugar. You might need to add that if you're
Saccharide
remember
means
that.
sugar.
Okay. Number 30, isomers. We did this on that worksheet
Number
that you
30.
did with the chemistry of carbohydrates. You said all monosaccharides were C6H12O6, but their shapes were different. That means they are isomers. Okay? Number 34, carbohydrates serve as food for cells. Saccharide means sugar. Number 35, double sugars are disaccharides. How are they formed? By condensation or dehydration synthesis. 37, 3 disaccharides. Okay? Flip to number 39. Complex carbohydrates are called polysaccharides. 3 examples of polysaccharides. You have starch, cellulose, and glycogen. Plants will store theirs as starch. Number 41. Animals will store theirs as number 43 as glycogen. Okay. Number 45, cellulose is found in the plant cell walls. That's it. For your
Done.
lab,
Don't.
for your lab, how did we test for monosaccharides? What did we use? We used Benedict's. What color was Benedict's?
Blue.
Blue. You want me to you want me to give these back real quick so that you can highlight them?
Mm-hmm.
Okay. Let me give them back and then I'll highlight.
Huh?
Hey, Abby, can you do mine?
Ay, ay, ay. Look at that product.
Okay.
Purple
So-
photo.
On your sorry, Sheila.
You gotta highlight mine too, though.
Yeah, you gotta highlight.
Okay.
Here, use the first page. This is a good one to use. Right here to highlight this. Okay, Benedict's test. Up there on the very front, Benedict's test, blue in color. So it will show you, make sure you write that it's blue. And when you add it, it'll change to any of the following colors: green, yellow, orange, or red. And that's a positive. And what does that tell you? That's a monosaccharide.
I think I should
Okay.
catch for this. Why does this thing keep moving?
All right. Iodine test. iodine was like a reddish, rusty color. When you add that, what color did it turn?
Black.
Black. So they say dark blue, almost black. So go ahead and highlight that. That's the positive. And that means that it's a, what type of saccharide? Non-mono. Polysaccharide. If you have two negatives, we know that it's a, right, so two negatives, you might want to write two negatives are a disaccharide. Okay? Procedure. Can you explain how you did the lab? Like how you do the test? So, okay, the Benedict's test, how you filled the beaker and put it on the hot plate, and this is called a hot water bath, right? So tell me what you did. You put the food in a test tube, and then what did you do? You diluted it with some water to moisten it up, and then what did you do? You put the Benedict's in it, and then what did you do?
You put it in the boiling water.
Yeah, the hot water bath, and then look for a color change, right?
I got that on.
Okay. When you did the iodine test, what did you do?
You put the food in, then you dilute it with water.
Mm-hmm.
Then you put the iodine
Are we
in the
supposed to highlight that?
dropper,
Yeah.
and you wait to see if it's a positive or negative test.
There you go. That's it. Okay? Can you explain that?
Mhm.
That's part of your fill in the blank.
Oh, okay.
Okay? How you did that, what you were looking for. So make sure you know what the chemicals were and what they were doing. What were these chemicals doing? They are identifying things, so they are called indicators, right? Because indicators tell you things or indicate things through color change. You did this when you did your pH lab. Did it change colors? Right.
Oh yeah.
So that's what you're looking for, the chemical change, okay? Of course, go back and look at your squirrel sheet. Go over those questions, look at your questions from that. Use your lab, use your notes. Look at the pictures again, your pictures with your chemistry of carbohydrates. Know the ratio. What's the ratio? 2 to 1. We highlighted that on the squirrel sheet. Okay? You know what carbohydrates are used
all?
for. Okay?
Is that all?
Yeah.